we talk about surface area to volume ratio, chemical reactions are affected by the surface area to volume ratio. And when we increase the surface area to volume ratio, the rate of the chemical reaction changes. So how does it affect the rate? Okay, so it's going to speed up the greater surface area to volume ratio. So if you have more surface for each little bit of volume, it will increase the rate of reaction. So that milk powder kind of blew up when you dispersed it. So they had lots of surface area to be able to, for the oxygen to react with that milk powder. So it'll increase the rate of reaction. So another example would be if you were to try to have a campfire. If you just try to burn a log by itself, it doesn't burn very efficiently because there's not enough surface and for the oxygen to react with to get enough heat or enough fire to keep the fire going. So in order to increase the rate of reaction or increase the fire and the strength of the fire, you need to increase the rate of reaction. So you need to increase the surface area for the molecules to be able to interact. So if you cut it up into small pieces, wood into small pieces, there's much more surface area for the oxygen to interact with, and it will then react faster, creating more heat, and then that will perpetuate a flame. Okay, so greater surface area to volume ratio increases the rate of chemical reaction. How does this relate to kinetic molecular theory? So kinetic molecular theory is something that we learn in grade 8 science. Okay, and kinetic molecular theory states that the more interactions of molecules, the faster the chemical reactions can happen. Okay, so the more opportunities that molecules have to bump into each other, the faster the chemical reactions will happen. So this relates to kinetic molecular theory, is that the more surface area allows for greater molecular interaction. More molecules to bump into each other. To react. Okay. So the greater the surface area, the more interactions they have, and that will increase the rate of chemical reactions. So basically there's two main ways that we can affect surface area to volume ratios. Okay, these are kind of independent of each other. Size, so if we have the same shape, okay, so we don't change the shape of it, so we just keep, for example, a sphere and increase the size of the sphere or decrease the size of the sphere, the surface area to volume ratio will change. So small objects or large objects have greater surface area to volume ratio. Well, as we increase the size of the object, there's less surface for each piece of volume is going to exist. So we're going to, for small objects, we'll have greater surface area to volume ratio, and large objects would have smaller surface area to volume ratio. So what has greater surface area to volume ratio? Small objects. Okay, that will increase the amount of surface area. What about shape? Okay, so we're not going to change the size of it or the volume of it. If we're just going to change the shape of it, we want to flatten out. Okay, wide and flat, tall and thin. So if you flatten out an object, will you increase or decrease the surface area to volume ratio? Well, we're going to increase the surface area. Okay, so we're going to increase that surface area to volume ratio. Okay, so if we have lots of small pieces, we're going to have lots of surface area. If we make it wide and flat, we'll have lots of surface area. So what is the most efficient shape to have the least? So if we want to do the opposite and have the least amount of surface area to volume ratio, we want to make things big, but the shape that will affect it is a sphere. A sphere will minimize the amount of surface to that will interact, so we have less surface area for the same amount of volume. So if we want to keep warm and decrease the surface area to release heat from, you make yourself more into a sphere. So this surface area to volume ratio shows up in science quite a bit. Okay, so it shows up in digestion. We have very long digestive tracts because we want to have lots of surface area to be able to absorb nutrients. Gas exchange in lungs. We have lots of tubes in our lungs that allow us to have lots of surface for gas to exchange. You know, we want oxygen in, carbon dioxide out. We need lots of surface for that to happen. So our lungs actually have a lot of surface area to do that. Okay, chemical reaction rates, cell size, evaporation, heat exchange. These are all things that are affected by surface area to volume ratio.